I'm David Ion, and today I'm out in the shop. I'm going to build a battery for my F-150. I've got a 2014 Ford Raptor, and so I'm going to take this shell and use these prismatic type cells and put them in this battery case with a BMS and wrap it up all nicely so I can put it in my Raptor. So that's the goal here, and let's get started. So first of all, when I started looking at this, I realized that this top will not quite fit. And the problem is these were made for lead acid battery cells. So I'm gonna have to cut some of this plastic out here to get the height I need with this multi-tool here. So I'm going to get to that and we'll see how it goes. All right, now I got that all cut out. I'm going to take an air hose and blow this out. That was pretty smelly and messy. I wonder if this air hose will take this plastic off. Decently. At least makes it easier to grab. There we go. Cool. All right, so now I'm taking this insulator paper. It's called barley paper. And I've measured around each cell. And I kind of want to double it over a little bit and overlap. So once I got around here, it was 13 inches, but I actually cut to 16. So I can put a little more insulation through there. Just if it's vibrating in the truck or something like that, it just doesn't rub. And then I came over here to make sure my bus bars have the clearance. And so they do have a decent gap there. So now I'm going to take these strips of barley paper that I cut, and they're self-adhesive, so I'm just going to wrap each battery up with this stuff, and then we'll go from there. All right, so I got these first three wrapped, and I'm just going to show you how I do one. I wanted to perfect it before I put it on video. And the reason you're doing this, one, it's an insulative trait. If these heat shrink on these batteries ever has a chafing problem or something, this is just an extra layer of protection. Plus it's just an insulative barrier. So, and this stuff is extremely sticky. There we go. I just kind of fold the corners over there. See how I kind of double wrapped it, just to give it a little extra. And these are lithium iron phosphate prismatic cells, and the reason I'm using lithium iron phosphate instead of lithium ion is because the math works better for 12 volts. Lithium ions top out at 4.2 per cell. So you end up with either 16.8, or if you try to go with 3 cells in series, you end up with 12.6. The problem is batteries, like 12 volt batteries, are more in the 13 something range. And so it ends up being better because these are more, they're like 3.6 volts. So you end up with 4 of them at 3.6, right around 14, a little over 14 volts. So it's better. I mean, your alternator on your car puts out more like 14 volts. And so after I did that, I'm going to just recheck with these bus bars and make sure that my current or my clearance here is still good, because I would like to wrap these in acetate tape as well, which is, that's just another layer of protection. Yeah, so we still got plenty of room. So I've got this black acetate here. It's high heat. You'll see something similar on like wiring harnesses that go up into your firewall of your car. You know, they'll be in wire loom, and then they wrap them in this too. So anyway, I'm going to wrap these batteries in this real quick and do the same thing. Just cut a bunch of 16-inch strips, and this peels. All right. So I'll show you how I've figured out how to do this. It's not perfect by any sense, but this is kind of a hassle. Every time you think you get the tape right, it comes off, or it sticks where you don't want it. So that's what I've kind of figured out, is if I do that and then take one side, smooth it down, there's kind of less inconsistency or sticking in the wrong place. But anyway, yeah, these are starting to look pretty good. So this will be a good barrier to protect the individual cells in this battery pack. Being in a truck application, it's kind of like putting on window tint or something like that. I need one of those little squeegee things that they use on window tinting. But I don't have one, so this will have to work. So now I've got a PhD in taping. I'm a master taper. All right, there you go. Got the last one done there. I'm going to check the bus bars again and make sure they're kind of the right length. Now these are going to be wired up in series. So yeah, there's still plenty of room there. That's good. So my next step is I'm going to tighten up these bus bars a little bit. We're wiring these all in series, so positive to negative, negative to positive. I'm going to tighten these up a little bit so I get a little bit of rigidity here, so I can wrap this in something called Katon tape. It's a high heat tape that I want to put around this outside here. You know, engines create a lot of heat, so, but I just want to get this kind of squared up here. And this is some funny looking yellow stuff here. I'm just going to go around the bottom and then the top and do the whole thing. I want to make sure everything's square with my bus bars and there's not too many gaps. Yeah, trick with this is don't let this stuff stick back together because it's almost impossible to get off sometimes if you do. And this whole pack is going to be covered, so I wouldn't really worry too much about the looks of this part because this almost feels like packing tape. And you just, it's kind of hard to get it perfectly straight. There's always a few bubbles in there. Like I said, that's not really an issue though. Yeah, I'm going to heat shrink this pack. So, like I said, not real worried about that. Okay, next up, here's my battery management system for this. It's a 4S 12 volt for lithium iron phosphate, 100 amp. And you have the lead wires that plug in there. So I'm going to go ahead and make the leads for this. And the way these work, it's 0 is always the black wire, and then they go up. So the next one is 3.6, and the next one's 7.2, and the next one is 10.8, and then the next one 10.8 plus 3.6. 14.4. Anyway, so I'm going to take and see which one of my little connectors here. This is a set I got from Wirefly on Amazon, and it just has a little bit of everything. This wire is really small, so looks like these are going to be probably 22 gauge ones on this. About as close as I can get. Let's make sure these rings fit pretty well. Come on, go in there. Yeah, they fit well. I might put them underneath the bus bars just to give it a little more too. We're also going to have to Loctite these for sure because you don't want that wobbling out. So I'm going to take these with my Klein wire strippers here and go down to the smallest one it has and just strip off a little bit extra. So there you go. Just enough to get to the end of the ring here. So I'm going to go ahead and strip these and make these, and then we will tune back in. So I've taken the these labels here so I can label each cell and then label each wire. Just it's kind of measure twice, cut once. I have this little Brother printer, so I just type in the numbers and print it out. And then these are just adhesive. So I'm going to, I've already put on most of these, but I wanted to show you how I do one. So this is just a 22 gauge Wirefly marine grade terminal connector, and you just put it in like this on the 22 gauge on this, and then crimp it down, and it's stuck. And then after this, you these are heat shrinkable, so that's why I like to use these. They've got a adhesive glue inside of them, so you can heat shrink them and make them watertight, since this is going to be an outdoor application. Now I'm going to take these and heat shrink them real quick. So it's just a Ryobi heat shrink gun. So, and the heat shrink keeps them weatherproof, but also from pulling apart as easy too. They're small wires. So I just finished heat shrinking the wire, and you can see how it kind of turns colors here. You can tell it's sealed real well, and you can see that little bit of glue coming out here at the end. So that's really well heat shrunk now. I've gone ahead and labeled all of these, and they're labeled on theoretical voltage, but what I want to show you here is you can kind of double check this, so to speak, with the multimeter here. So I always like to think of electricity kind of flows like water. So anyway, so I'm going to go to the 0 volt, and then the next one will be close to 3.26, and then the next one over here, yeah, 6.5, close to 7.2. Remember, these batteries are not shipped fully charged, so this one's 9.7, and then your main out positive is 13. So we're good to go there. Okay, so I've attached each one labeled to the corresponding place that it goes. So your black is always 0, and then your next one would be 3.6. Your next one 7.2 and 10.8 and 14.4. So the next step is, and I'll see if I can't zoom in a little closer here. You need to take a voltmeter and check and make sure that each one of these is actually getting power and everything correctly, because otherwise you don't want to put together the whole thing and then all of a sudden realize that you've got something that's not working. So I will set this right here, and we'll check each one. There's these tiny little pins in here. So you put your voltmeter on volts, and then you go to the 0, and these are very tiny. So yes, first cell 3.2, second 6.52, third 9.77, and 13.02. So we're good. Now we can, the next step will be, we've got to take the BMS here, and the B negative goes to the battery negative. The P negative goes to your negative on top of the battery, on this case, in this case, the underside. But